there is our histogram. Okay. Computers make all of this stuff so easy these days. You utilize technology whenever you can. It's useful. It's mostly user-friendly. Way too much about that. All right. Histograms. The appropriate use of histograms. When should we use a histogram? Well, as I said, histograms are probably the more popular choice of displaying quantitative data. And typically, you're going to use your histogram when you have large data sets. The book says large is anything over 50. You can interpret large however you want. But that's a good rule of thumb. If you have more than 50 data points, histogram is probably going to be a good choice to use for your data display. One of the drawbacks of using a histogram, though, that doesn't show up with the dot in the stem and leaf plot, is that if I just gave you this histogram and said, okay, here's the data displayed for number of touchdowns per team in the NCAA. One of the drawbacks you have here is that you have no way of taking this graph and figuring out what the original data looked like. There's no way that I can figure out how many teams scored 38 touchdowns. I can't get that from this. And so that's somewhat of a drawback that we have to balance with the sort of pretty picture that we get out from this particular data that we have. Okay? So you really do have these trade-offs of the usefulness that these things can give you versus the amount of sort of the amount of autonomy that you want with your data. Okay. All right. So what else do you need to talk about with graphs? The last thing I'm going to talk about with graphs, and this is not just with histograms, but with any graphs we have. We're going to talk a little bit about sort of what should we look for, and what kind of things are important when dealing with graphs of quantitative data. So when looking at quantitative data, there are a couple of things that you should look at and you should notice when you are presented with this. The first thing you should look at is you should look at the overall pattern in your data. Okay? What does the overall pattern of your data tell you? Okay? When I talk about overall patterns, what I'm talking about are there clusters of data? Are there gaps in our data? Are there unusual response values? These are the kind of things that we should be looking for when we're talking about the overall pattern. Okay. For example, in this data that we have here for our touchdowns, are there clusters of data anywhere? Are there little clusters here, little clusters there, little clusters, sort of way down the line that we can identify? Not really. I mean, there's, sort of the majority of my data is all sort of right here. So if you wanted to, you could say this is a big cluster of my data. But there's no little individual clusters here and there that are sort of defining the overall pattern that we have in our data. In this particular data, there's no gaps. There's no gaps between here's some values, nothing in between here, here's some more values. There's nothing like that that goes on in this one. Also in this particular set, there's no sort of unusual responses. It doesn't seem. When I'm talking about unusual responses, if you look at something like this, suppose that I give you a histogram that looks something like this. Okay. Is there anything unusual about that collection of data? And you have all this data over here, and again, I don't have any numbers on this, so this may be like, well, actually, I don't know what you're doing. But imagine that there's the majority of our data right there. There's this huge gap, and then there's this guy out here. Okay, that's unusual. That seems to be an unusual data value. Something that you need to look for when you're looking at these kind of graphs. You may go back and say, okay, why is this value out here? Where did that value come from? Why is it so different from the rest of the values of the graph? All right. The next thing we want to look for is we want to look for sort of the high points. Or the, what are called the modes. In statistical term, the word mode refers to the most frequent response. So we want to look for things like that when we're analyzing our data. If we look at this set of data we have here with the football one, okay, notice that there's only one high point. There's only one mode in this case. Okay? In comparison to this, and this again sort of depends on sort of your view of this data. This collection of data here sort of has two high points. Here's one high point. This point here, it's not as high as the first one, but it's a reasonable level above the rest of the data, so you can interpret it as a high point as well. When talking about this, there's lots of different terms that you'll see thrown around. One is what is called unimodal. Unimodal just means there's one high point. There's also what's called bimodal. Bimodal, as you may guess, means what? Two high points. Bimodal data, a bimodal picture would look something like this, for example. Okay. This would be an example of data that's bimodal, the two different high points at different spots. Okay. And again, you can increase the number of high points by changing the prefix in front of modal. You could have trimodal, quadmodal, also quadmodal, all those other different things. You can talk about all those different things all you want to blue face. Okay, just talking about things like this, it's important to analyze or recognize where those high points are coming from. And the final thing we'll look at is what's called the shape of our data. And when talking about the shape, what we're wanting to describe typically falls into one of two categories. We're talking about whether it's symmetric or what is called skew. Symmetric, hopefully it's good with that one. Symmetric data is basically just a graphical display of data in which there is a clearly defined middle point, and the data on one side of that middle point matches up pretty closely with the data on the other side of that middle point. Okay? So an example of symmetric data would be something like the football data we had is an example. This is another example of symmetric data. Okay. Along in addition to that, something like this is also symmetric. That's also symmetric data. You can clearly identify there's a middle point where the data on each side of that middle point sort of matches up pretty well. Now, in statistics, when we talk about symmetric, we're not saying it has to line up exactly, but we're looking for sort of something that comes pretty close. Okay? something that comes pretty close. It doesn't have to be perfect, but something that's close. This, for example, this right here is also sort of symmetric in shape. Okay? It doesn't line up perfectly, but you can sort of see that, yeah, there is a little bit of similarity. If I cut my graph right here, there is some similarity between the shape on this side and the overall shape on this side. Okay? They do sort of match up in a reasonable way. Okay? So that's what symmetric data is. What about skewed data? Well, there are two types of skew that we can talk about. And skewed data, basically, when we talk about skew, we're talking about being pulled. So we can talk about skewed left data, and what's called skewed right data. And when we're talking about skewed data, what we're really doing is we're saying, if I look at the overall shape, okay, and I'm going to move away from these histograms for a moment and just draw sort of graphs like you would see in an algebra class. When you're looking at data, and we'll start with this one. This is an example again of what? What would you say? This is symmetric data. Okay, this is a symmetric picture, symmetric shape. And when we're talking about skew, what we're really doing is we're looking at these two pieces right here. These are what are referred to as the tails of our graph or our distribution. Okay. When we start talking about data being skewed left or skewed right, what's happened to our data is that someone has decided that they're going to start pulling on one of these tails. And in pulling on one of those tails, it has caused our data to have a very long tail in one of two directions. Okay? So for example, if we take a look at a picture like this. Okay? With this picture, what's happened is someone has grabbed that right side tail and just sort of started pulling on it. Okay? And in doing that, that has skewed our data to the right. Okay? So this is what is referred to as a skewed right distribution. Okay? The tail has been pulled to the right a lot further than the tail on the left has. And in a similar way, we can look at someone pulling on the left side tail. Something like this. This would be our skewed left data. Okay. Now, distributions like this are real. They show up a lot. Okay? An example of something like skewed right would be income level. Incomes are an example of skewed right data because there are lots of people who make money in this range. There are not a whole lot of people that make billions and billions of dollars. Okay. Skewed left data. We'll do something a little easier. We'll talk about lifespan. Okay. Typically, people live longer. You have people that die early, but typically in our world today, medicines and things like that have increased the lifespan of most people, and so you're going to have data that has a skewed left shape.
That's great. That would be skewed.
All right. Symmetric distributions. Somewhere you might see something like this.
Much people, 50%.
IQ scores have sort of this nice symmetric shape to them, or at least they're supposed to. All right, there you go. That is the majority of the graphical picture stuff. Again, remember, quiz on Friday. We'll cover everything up to section 2.2.